Alright, your cliffhanger is over. Time to learn how to move across the equation by using the mole road. And so what I've done here is I've taken two of those flux capacitors and put them right next to one another to help us understand what's going on. So you remember me explaining the flight hub when you're flying across the United States. So let's say you're going from hub to hub, and that is how you get across an equation. So let's say that we start up here being the aluminum chloride, and we have 20 grams, and I want to know how many liters of hydrochloride gas are formed. So we have 20 grams. Now, in order to start off with, we have the 20 grams of aluminum chloride, and we are going to divide by the molecular weight, which is the step written right here, and the molecular weight, which you can find in the periodic table, which I've pretty much already done here, because aluminum is right over here, and its weight is at the very bottom. Chlorine is over here with its weight at the bottom. There are 3 chlorines, so I multiplied it by 3. And I got a molecular weight of 133.33 grams per mole. And so what we're going to do is, since it's grams per mole, you take the inverse to get moles on top. So you get 1 mole, and you get 133.3 grams. And this is all of aluminum chloride. Try to remember to keep the compounds with you as you go. This is part of keeping your units. If you lose your units, you can lose your place. So now we've gotten to moles, which is right here. But we need to get to moles over here. So how do we get across this bar right here? Well, we simply look at the prefixes. Take the fraction of the prefixes. Now, whenever you're in math, if you want to get rid of a unit, you divide by it. If you want to gain a unit, you multiply by it. It's a simple rule, right? So we want to get rid of the moles of aluminum chloride, so we're going to divide by it. Since the prefix is 2, oops, just erased it, 2, we have 2 then moles of aluminum chloride. And since we have 6 moles of hydrogen chloride, we're going to multiply by that. HCl. And now we are here, but we want to get here. So we multiply by 22.4 liters per mole. So 22.4 liters divided by 1 mole, and this is of the hydrochloride gas. And so through the course of this, I'd already figured it out, but I'm going to check my math now, and you can go with me. So what we're going to do is we're going to take 20, divide by 133.33. I don't have a 3 in there, but there it is. It really does exist. And then we're going to multiply by the 6, divide by the 2, multiply by the 22.4, and I get 10.08 liters of hydrochloric gas. Now, isn't that kind of cool? I think it's cool. So now I'm going to try something else. So what I'm going to try now is say that we have 2 liters of hydrogen gas. Now we have a limiting reagent because one of these is going to run out and one of them is going to be in excess. So the first thing we need to do is calculate which one will run out and which one will be in excess. And we'll use a very similar method. So I'm just going to erase this and rewrite it just for practice so you guys can get plenty of practice at doing this conversion. This is stoichiometry at its best. So I'm going to start with aluminum and go all the way to hydrogen gas in terms of liters. So once again, I'm going from here to here. And then once I find out what this number will be, I compare it to the 2 liters. Now, if the number is greater than the 2 liters, that means that I have aluminum chloride in excess. If this number is less than the 2 liters of hydrogen ions, that means that hydrogen is my excess and aluminum chloride is my limiting reagent. So we're going to start by doing 20 grams of aluminum chloride, and we're going to set up another conversion factor. I know you guys will love these conversion factors. I know I do. And so we're going to divide by the molecular weight, which is 1 mole at the top, over 133.33, that looks like a 7, 3 grams, and this is of the aluminum chloride. Always remember the compound, and always try and write it correctly, which I'm failing at right now, but it is currently 1 in the morning, so just bear with me. And now we have to go by comparing the prefixes and setting up a mole ratio. We have a 2 in the aluminum chloride. We want to get out of aluminum chloride, so we divide by it. To get out of something, you divide by it. To get into something, you multiply by it. And we need 3 hydrogens. So we have 3 moles of H2, and we're dividing by 2 moles of aluminum chloride. And so just to follow what we're doing, aluminum chlorides cancel out, grams of aluminum chloride cancel out. And so now we are in moles of hydrogen gas. We need to get to liters to make that comparison. And so what we're simply going to do is multiply by 22.4, that looks like a 3, I'm writing too fast, 22.4 liters per 1 mole of H2 gas. Now if you'll notice, the moles of H2 gas cancel out. The only unit left is liters of H2 gas. This one I have not figured out yet, so I'm going to plug it in to the calculator. And so we have 20 divided by 133.33 times 3 divided by 2 times 22.4. We have 5.04 liters of hydrogen gas. That means for 20 grams, I'm just going to eliminate this cross through. For 20 grams to fully reactive the aluminum chloride, we need 5.04 liters. We don't have that much. We only have 2 liters. This means that hydrogen gas is our limiting reagent, because we don't have enough to use up all of the 20 grams. There will be some left over of the 20 grams. You can actually figure that out by starting with the hydrogen, going through this whole process here backwards, which is not very hard. You just simply follow the mole road backwards. But once you've found the limiting reagent, say if you want to find the number of atoms, you just then go from hydrogen in volume 2 moles, then compare the fractions right here, and you will get number of moles, and from number of moles you will simply multiply by Avogadro's number, which is 6.02 times 10 to the 23rd, and you will have number of atoms. So that's all for now.